Dear students, here we will see method of variation of parameters to find out the solution of ordinary differential equations which are linear. So this presentation is based on the book Mathematics 2 for BE Semester 2 by Dr. Shailesh Patel, Atul Prakash. You know very well that till now in the previous presentations we have seen the method how to find complementary function, then how to find out particular integral by considering different cases of right hand side function equal to e raised to ax, sin ax, cos ax or polynomial. And then also we have seen one more method of undetermined coefficients. Now let us see the new method of variation of parameters, and one question also coming in the examination based on this method. That means by asking that solve the equation by using the method of variation of parameters, then we shall have to use only this method. No other method we can use to solve the equation. However, it may be solved by using other methods. So this method is also very simple, and this we will discuss now. You know, the nth order differential equation can be written into this form: y raised to n plus a n minus 1x, y raised to n minus 1 a plus dot 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 plus a1x, y raised plus a0 x, y equal to rx. So here we have written a n minus 1x, a1x. That is, sometimes these coefficients may also be function of x or maybe constants, but mostly we will focus on the constant coefficients. So here the solution can be obtained very easily, very simply. We need to find out yp. Yp can be written into this form. First term we will see. Here it is written y1 integration w1x from wx into rx dx. Now let us understand what are these. What does this states? So here when we find out yc complementary function by using an appropriate method, we write down this in the terms of yc equal to c1 y1 plus c2 y2 plus c3 y3 like this. Then the functions, different functions we can identify from this y1, y2, that means coefficients of c1, c2, c3, y1, y2, y3, identify them. Then from these functions we need to find out first wx. Wx is nothing but a Wronski. This how to find that we will discuss in detail. Then after finding wx, we can find out w1x from this. Rx is nothing but the right hand side function in the given equation. But here you must remember that the coefficient of y raised to n must be kept as 1. If it is some other constant or function, then you need to divide the whole equation by that constant. So then after finding w1x, wx and y1 is already there. This is determined from yc. We can find out the first term of the solution very easily. Similarly, we can find out the second term, third term, and so on. Now let us understand what is wx. Wx is Wronskian. Wronskian is the name of the mathematician, Wronskian, and this is nothing but the determinant, simply determinant. The name, by looking to the name, we can predict that this may be some difficult task, but it is not difficult task. It is the determinant. That means in first row we need to write down y1, y2, dot 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 y1, which are the solutions determined from yc. That means complementary function. In second row write down its first derivatives. In third row write down second derivatives, and up to nth row. In nth row write down their n minus 1 derivatives. Then solve this determinant. We can find out Wronski. Now we can determine w1x because this we need from wx. Wx is everywhere there in all the terms in denominator, and rx is also everywhere in all the terms, but in all the terms the numerator is different. That means w1x, w2x, wnx. This we can determine from Wx directly. That means here when we want to determine W1x, then simply in Wx replace the first column by putting 1, 0, 0, 0, 0 and so on. So on. Okay, sorry, 0, 0, 0, 0, 1. Where we want to find out W2x, then second column can be replaced by 0, 0, 0, 1. If we want to find out W3, then third column can be replaced by 0, 0, 0, 1. So it is very easy to obtain W1x, W2x, W3x from Wx directly. Let us consider some particular case of order 3. That means when the differential equation is of order 3, then we know that we get three different solutions, y1, y2 and y3 in yc, because yc can be written as c1y1 plus c2y2 plus c3y3. So after finding this, we can determine Trotsky y1, y2, y3. Their first derivatives in second row, their second derivatives in second row. So it is a 3 by 3 matrix determinant. We can solve this easily. Then to determine W1x from this, replace first column by 0, 0, 1. To determine W2 in Wx, replace 0, 0, 1. W3x is also to determine W3x, replace third column in Wx by 0, 0, 1. So this is very simple task and very simple to find out Wx, W1x, W2x, W3x. So once if we find out them, then there is no further process or no hard process. Simply we need to find out, put out their values in this one, this formulas, and we can find out the integrations very easily. Or else we can also find out these integrations separately and then put their values with y by assuming this first integration is ux, second integration is vx, third integration is wx, like this. So now we consider one example. Here you can see that the example is given in the form of y double dash minus 4y dash plus 4y equal to e raised to 2x upon x. So we will use the method of variation of parameters over here. In examination it will already be given. So first we need to find out yc, that means auxiliary equation, m square minus 4m plus 4 equal to 0. So m equal to 2, so yc equals c1 plus c2x e raised to 2x as usual. So from this we can identify y1 and y2. It is second order, so two solutions we get y1 and y2. So y1 is the coefficient of c1. This is e raised to 2x, because when we open the bracket we will get e raised to 2x here. And the coefficient of ct, which is y2, it is x raised to x into e raised to 2x. And right hand side it is already given e raised to 2x over x in the given equation. Then w, first we need to find out w, that means Wronskian of y1 and y2. This is in first row, write down e raised to 2x, x e raised to 2x. In second row, find out the derivatives, first derivatives only, because it is a 2 by 2 determinant. Then by solving this determinant we can get a solution. We can do first we multiply this opposite diagonal, that is e raised to 2x into bracket e raised to 2x plus 2x raised to 2x bracket over minus this one main diagonal, then minus opposite diagonal, that means minus 2 e raised to 2x into x e raised to 2x. So this, from this we will get, after simplification, e raised to 2x. Now to determine w1x, as I discussed, replace the first column by 0, 1. If it is 3 by 3, then put 0, 0, 1. If it is 4 by 4, then put 0, 0, 0, 1. It is 2 by 2, so put 0, 1. So 0, 1 here, and second column will remain as it is. Solve this into this, 0 into this, minus 1 into x e raised to x. Then to determine w2, replace second column by 0, 1. First column will remain as it is. So you can see it is obtained e raised to 2x. Then yp is ux y1 plus vx y2. We can also find it a common statement, but it is better to find out them separately, so we can give good attention on finding ux and vx. That means the integration. So integration, we know that w1 upon w into rx dx. It is w1, put the value of w1 from here, minus x e raised to 2x divided by e raised to 4x, which is the value of w, into rx, because rx is the value this one. Then simplify this. You can see e raised to 2x into e raised to 2x is e raised to 4x. This will be cancelled with the denominator. X will also be cancelled, so it is minus dx. But dx is going to be an x, so minus x. And similarly, to find out vx, vx has the formula, same formula. Simply instead of w1, we would write down w2. And following the same process, we can find out the integration log of x. Then put their values in yp. Yp equal to ux y1 plus dx y2. So the general solution is y equal to yc plus y2. This is yc. Now let us see another example. Here solve y double dash plus 25y equals fx. Now here you remember one thing, that in the previous lectures when I discussed the three different cases of right hand side, the rx equal to e raised to ax, sin ax, cos ax, and x raised to n, that I totally clarified that the second case, that means rx equal to cos x and sin x, cannot be applied for sec function, tan function. But if we are given in equation sec function, tan function, then it is better to use method of variation of parameter. However, the name of the method is not given. It is a simple method. We can also use the general method that I did not discuss, because without doing this also we can solve by using other methods. So general method is a difficult task. So method of variation of parameter you can use here. So as usual, find out the auxiliary equation m square plus 25 equal to 0. From this find out yc. Yc is c1 cos phi x plus c2 phi x. So y1 is coefficient of c1, that is cos phi x, and sin phi x is our y2, and rx is right hand side function. This is very simple. So Ranskin is y1 y2 in first row, that means cos phi x sin phi x, its derivative second row of solve this determinant, we get phi. Then w1x, as usual, we replace first column by 0 1, and second column will remain as it is. This can get minus sin phi x. W2x we can replace in wx the second column by 0 1, so we can get cos phi x. Then yp is nothing but y1 into ux plus y2 into dx. So here we have solved in the common statement, rather than to find out them separately, because in first example we solve them separately. You can do in both the ways, if as you like, and as per your convenience. So y1 is cos phi x, integration of minus sin phi x over phi, and this is after substituting the values of w, w1 and w2 and rx. So here we get integration of tan phi x, and here we get integration of dx. Simply integration of dx is x, it is very easy, but integration of tan phi x is the formula log of sec phi x upon phi. So this is also very simple task. Method of variation of parameter is also very easy to use. The general solution is y equal to yc plus y2. As a third example, let us see here. You can see that d cube y by dx cube plus dy by dx equal to cosec x. Here the function is cosec x is given on right side, but as usual, we want to use here again. You note that if method of variation of parameter name is not given, it is better to use this method only in this equation, because this is the simple method. But if the name of the method is given, then you must have to use that method. But if name of method is not given, then you can use any method. So auxiliary equation is this one. You can find out the three roots, 0 and plus or minus n. So we can get the solution, right? Y is equal to c1 e raised to 0x. E raised to 0x is 1. c2 cos x plus c3 sin x. So here we will get third order equation. So we will get y1, y2 and y3. So y1 is the coefficient of c1, this is 1. y2 is the coefficient of c2, that is cos x, and y3 is the coefficient of c3, that is sin x. So here one thing you note that you can also alter the order. That means you can assume sin x as y1, cos x as y2, or this as y3. But once if you have denoted them as y1, y2 and y3, then you cannot change their order. After them you cannot change their order. So whatever you have given them names, y1, y2, y3, keep them same till the last term. So Rx is the right hand side function cos x. So W is 3 by 3 determinant, because there are three solutions. So in the first row write down y1, y2, y3, which are 1 cos x, sin x. In second row write down its derivative 0, minus sin x cos x. In third row, write down again its derivative, that is derivative of second row in third row. So you can get this solving. The determinant is very easy to solve because in first column 1 0 0, so only you will require to solve this upon first column. So no need to solve this one only, this part only. 1 into minus sin x into some minus sin x plus sin square x, and here is minus cos x into minus cos x, because my one more minus sign will come back. So sin square x plus cos square x is 1. Then w1x, to find out w1x, here you need to replace the first column of w by 0 0 1. So 0 0 1, and the other columns will remain same. Here again 0 0 are there in first column, so need to solve on third first column only. You can find out very easily. So 0 into something is 0. The pattern is just like when we solve this upon first row, then we can write down 0 into that determinant, that means this minus cos x into that 0 1 and cos x minus sin x. Likewise here we follow the same process on first column, that means 0 into something is 0, this 0 minus 0 plus minus plus pattern, minus 0 into something, this will give us also 0, so we will not focus on this. So now plus 1 into its minor is cos x into cos x plus sin x into sin x, that is 1. To determine W2, we replace second column of W by 0 0 1. So first and third column will remain same, so 0 0 1. So again here you can solve this upon first column or second column, but it is better to solve this upon first column because there is only one here and you can solve this very easily. So 1 into 0 into sin minus cos x, so minus cos x. Similarly, to find out W3, replace the third column by 0 0 1 as in this case. So we will get, after solving, it is also very easy. They solve this upon first column because 1 0 0, the other two terms are 0, so directly we get the term 0. So it save our time. So now ux is, we will find out required three solutions are there. So y1 into u plus y2 into v plus y3 into w, that is our y2. So we need to find out ux. We'll separate out, find out the integration separately. Integration of w1 upon w into rx dx. Vx is w2 upon w2 into rx dx. Wx is w3 upon w rx dx. Then put their values for whichever we have obtained, and whatever the functions remain in integration, we will, after integrating, we get the proper answers. And then put finally in the y3 ux into y1, dx into y2, wx into y3, u, v, w are obtained, y1, y2, y3 are already there, determined from yc. So the general solution is y equal to yc plus yp. Now you have here some of the examples to practice yourself. You can solve each of the examples given in this exercise yourself, and answers are already given. You can verify them. All the questions are very simple to solve. Simply you need to find out positive and relevantly w1 w2 like this, and use the formula, proper formula. Formula is also very easy to remember, and there is no difficulty in this case. So students, if you find any query, any difficulty, then you can ask me the queries directly, contact to me. So I will reply each of your questions, and I will explain to you at that time, at that moment. So practice yourself, and without practice you cannot do anything. So practice is required in mathematics. So I hope you will do as per the guideline given in this presentation. So thank you, thanks to all, thanks a lot.